What you see on the screen now is a reminder that this advisor webcast is intended for information purposes only. Any features or functionality described for Oracle's product remain at the sole discretion of Oracle.
Hello, good morning everyone. My name is Sumendra. Today we'll talk about another interesting topic on SQL Tuning. It's about Oracle Database 19c, SQL Tuning using plan stability methods like SPM and SQL Quarantine. Now, if you remember my previous topic, if you have gone through some of them, like what you need to do when you upgrade from one release to another, like 19c, or if you have gone through my training on SQL T, how to analyze a SQL tuning problem. So this is like a continuation of that, because when you upgrade your database from one release to another, you will find a few SQLs which are not going to run as well as it did in older version. Also, sometimes in the same production database or UAT, you will find that same SQL statement is sometimes regressing. It's having more than one execution plan, and sometimes the difference among the different execution plans for a SQL statement is very high. As a result, you cannot let it run with so much difference in performance. When we talk about that time we talk about plan stability methods, or what we can do to maintain a better plan for a SQL statement. And that's really what we are going to talk about today. So I'll briefly talk about SQL plan management using not just SQL plan baseline. There are various other features available in Oracle database you can use. Also, we'll talk briefly about SQL Quarantine feature, which has been introduced in Oracle 19c. I'll also expand on the methods available in Enterprise Edition versus Standard Edition 19c databases, but it also backward compatible, and I'll talk about older version where some of these features are available or not. So I kind of try to expand and include the other release as well. Now, we'll discuss how you can implement some of the plan stability methods, what you can do if those plan stability methods are not working, and then we'll finally discuss how SQL Quarantine feature in 19c complements the SQL plan management feature. Now, as you know, cost-based optimizer has to hard parse a SQL when it runs first time to come up with an execution plan. And normally that execution plan is the plan with the cheapest cost by default. That's how the optimizer works, unless you want to influence with some hints and all. So we always try to generate a plan with the cheapest cost. Now, to generate that plan by the optimizer, it needs various inputs. For example, it will look for table statistics, index statistics, column statistics and histogram, extended stats, system statistics gathered at database level. It will look for optimizer parameter settings, whether you have set it at database level, session level, or even for a specific SQL using OPT_param hint. It will look for optimizer related bug fixes. It will look for any bind variable and related bind values it has, so that it can activate related features to the bind, and all of them will help decide the optimizer what is the cheapest cost plan it can come up with at the time of hard parsing. Now keep that in mind. If same SQL is hard parsed tomorrow, it may come up with a plan, and the cost of that plan may be different from what it is today, again because of so many different inputs it has to use. When it came up with the cheapest plan and ran it. Then if it hard parses again for any reason, then it may come up with a different plan sometimes. It does not happen often. It does not happen for every SQL, but it can happen for a few SQL. And when it does happen, so that time we really need to think of any plan stability for that particular SQL if the timing of that SQL execution timing is very important, right? So if that is the case, then one of the methods we recommend is to use SQL plan baseline of the SPM feature. But we'll talk about more options other than just SPM for usage of plan stability. We introduced SQL plan management feature in 11G. We recommend that you use it for a small number of SQLs which are regressing or which have potential to regress based on your test when you are upgrading the database or in an existing database. So you should use this feature. Now this feature works in 3 steps. So it's like a 3-step process. In the first step, you have to capture one or more SQL plan baselines. You have to activate them in a way so that optimizer can use them. Then in the next step, when optimizer does use it at the time of hard parsing, it will select one of the baselines if possible. And if not, then it will create a new plan. So we'll discuss about that. Then the third step is plan evolution, which is specific to SQL plan management. Other plan stability methods do not have the plan evolution. That is also the reason why we prefer to use SQL plan management feature for plan stability as and when possible. Now, we use SQL ID to uniquely identify a SQL for the purpose of this presentation. That is what we are going to do, to select a particular SQL which has been identified for plan stability. But before 10G, so we introduced SQL ID in 10G. Before 10G, we had address and hash value to also uniquely identify a SQL statement. But we are not going to use this in this discussion. Starting 12C, we also enhanced SPM by adding execution plan data along with stored outline and other information, so that if the baseline could not be reproduced, or if we wanted to see how the baseline plan looks like, we have that information readily available starting 12C. But we introduced this SPM feature in 11G, and that time we did not capture the execution plan. Now, SQL plan management is the preferred method for plan stability, but this is not the only method available to provide plan stability for a SQL statement. You can find details about the baselines which are captured as part of SPM in the view DBA_SQL_plan_baselines. And you will find that view does not have the SQL ID, rather it has a signature. It generates a signature based on the SQL text for a particular SQL ID. Now, not all other views, like say DBA hist SQL text or DBA hist SQL stat, for example, they do not have always a signature to readily join with this view. So there is little bit challenge, but it can be overcome by sometimes generating a signature from a particular SQL ID or SQL text, and then you can join it with this view to identify specific SQL. Because sometimes you may have captured thousands of SQLs, sometimes they may look very similar, and it would be hard to distinguish which one is what. Also, if the SQLs are very similar in the syntax, it may also sometimes generate same signature, and that another reason you may have to be a little more careful to choose which SQL you are looking for and checking its related baseline. Anyway, so in Oracle 19c Enterprise Edition, you can use all available plan stability methods. For example, you can use SQL Plan Management, which is the preferred method for plan stability. Second preferred method, I would say, is COE profile or custom SQL profile. Third is stored outline. Fourth is adding hints non-invasively to a SQL statement using SQL Plan Management feature. There is a note at the end of the presentation. I'll show it to you. I find that very handy and have used it for many customer issues to provide plan stability. You can also add optimizer hints directly in the SQL statement, but that will need change of the code. Sometimes that is difficult. That's why I have tried to use optimizer hints non-invasively as and when possible. And I would like you to try same way if you can. Now, you should also try to avoid hints randomly all the time, even if you can use it or you know how to use it well, because sometimes if you add hints and then you upgraded the database, then this SQL may be restricted and may not be able to use certain enhanced features. That's why we caution about it. But if you really need to add some hints for plan stability to make a SQL run better, you can use it or you should use it. I do not see any problem with that. Now, SPM and COE profile, they will not work for any SQL which are being generated dynamically through certain type of application. Simple reason is most of the time they will end up creating a little bit different SQL which will have different SQL IDs. So they may look very similar syntactically, and they may even use same plan or could use same plan, but that is a problem for plan stability with any tool which dynamically generates SQL. Now with standard edition 19c, you have less option for plan stability. For example, you can use stored outline. You can add optimizer hints directly. You can also create a single SQL plan baseline. In fact, you can convert a stored outline into a baseline, single baseline starting Oracle 18c and 19c, and use it for plan stability. However, you cannot use SQL profile or COE profile in Oracle Standard Edition. Simple reason is that SQL profile is part of Tuning Pack, and Tuning Pack is not available in Standard Edition databases. Now, even though you can use stored outline both in Enterprise or Standard Edition 19c or in higher release, still we do not recommend it for various reasons. One of the reasons is that stored outline has been deprecated starting Oracle 12c. Also, stored outline cannot evolve over time like SQL plan baselines. You can migrate the stored outline into a single SQL plan baseline starting 18c and 19c even in the standard edition and use it. Disadvantage of stored outline is that you can activate and use one stored outline at a time compared to SQL Plan Management, where you can activate more than one baseline plan at any point in time and then let optimizer choose one of the baselines which you have enabled and accepted. But in standard edition, again, the restriction is you can have one stored outline or one baseline activated at a time. Now, a lot of you may have used SQL profile as a plan stability method. in 19C or in older versions, but it is actually not a real plan stability method. I think it is one of the most misunderstood features in the database. It is actually a row estimate corrector to try to get to a better performing plan. It is generated using SQL Tuning Advisor tool. It becomes ineffective over time because of data changes in related objects. So what will happen when it becomes ineffective? You will see that same SQL profile is being associated with a good plan and a bad plan, or one in between. It will show it is being used, but it is being used and really not doing much to get to a better performing plan. Also, it affects the costing at hard parsing time. That's why you should not use it when you have a real plan stability method like SQL Plan Management or COE profile. So that time you should disable your SQL profile, which you may have used for short-term plan stability. And then for long-term, you should use SQL Plan Management or COE profile. And please make sure to disable the SQL profile. Just use one method. Here is an example of a SQL profile. You can note a bunch of lines with OPT estimate hints. And in those lines, you can also see scale underscore rows equals some value. So that's why I call it a row scaling or row estimate corrector. You do not see real optimizer hints like use NL, use hash, leading hint, ordered hint, things like that. It is also not saying what specific optimizer features enable can recreate this plan as it is. That is the reason it cannot provide long-term plan stability, and that is also the reason why I recommend that you can still use SQL profile as and when needed, but you should think of it as an workaround or short-term plan stability method. Compared to that, we came up with another method called COE profile, or we call it custom SQL profile, and I use it as a complementary method with SPM. When I had problem using SPM, I have used COE profile a lot of time to provide plan stability for many critical SQLs for our customers. Now, COE profile was developed when 10G was released by our Center of Expertise team. That's why I sometimes call it a father of the SQL plan management feature, because if you recall, SPM was available starting 11G. But you can still use COE profile in 19C or 20C, which is recently available. You can provide plan stability using it when a SQL is regressing, and behind the scene, it is actually using stored outline to maintain that plan compared to SQL profile, where SQL profile do not have stored outline hints. Now, same recommendation applies here. If you are using COE profile, please make sure to disable or drop the SQL profile. We should use one method. Let me show you how you can create a COE profile. It is very easy to use. All you have to do, you have to download a script called sqlt.zip file using this particular node, 215.187.1. Take it to your server, unzip it, then go to the directory sqlt/util, locate the script coexfr SQL profile.sql. It needs two input. One is the SQL ID, second input is the plan hash value for which you want to provide plan stability or create this plan stability method. Now, you need to be a privileged user like sys. So log in as sys, use the script, run the script with SQL ID and plan hash value. Here I am showing the plan hash value ending with 7117. So it will create a script like this. So it has a naming convention starting with COE underscore. And you can see here we also provide the SQL ID, and the plan has value name. Here is a typo I have, but the actual name is in the next page here. So you can see the proper script generated. And again, you can generate this COE profile in one database, take it to any other database, or you can generate in same source database and destination database, whichever is necessary. Because sometimes you may see that you have a better plan in production, but not so good in UAT or vice versa. So you can move the plan around very quickly and easily because it is a script which you have just created. So you can generate this and then you can execute it in the destination database. So all you have to do, log in as this and run the script name. Next time the SQL hard parses, it will use the script, and then you can rerun your SQL. You can verify whether you are able to use the COE profile. Sometimes you may have to flash the cursor from your single instance or rack database. Sometimes I have done by flashing the whole shared pool or particular cursor, whichever works. But good news is in 19C, I see that as soon as I create this COE profile, it can pretty soon take effect and optimizer start hard parsing automatically and start using it. Here is an example. So you can see here I used a SQL ID ending with 41YG, and here is the plan, has value ending with 7118. And once I rerun the SQL and verify under the notes section, you can see it's clearly showing it is able to use the COE profile, which I have just created and implemented for this particular SQL. So you can do the same for your specific problem SQL, which has multiple plans, and one of the plan is far superior than the other plan in terms of performance. Now, if you do not need the COE profile, you can disable it, and then later on you can drop it. You can find it from DBA_SQL_profiles view, which is used to keep both the vanilla SQL profile from SQL Tuning Advisor as well as the COE profile. It uses same basic set of base tables in the C schema to maintain this information. And the optimizer will seamlessly use it when you hard parse the SQL next time you run it. So there is no need to change your actual SQL code. And that is the beauty of this COE profile. Now compared to that, now let's expand on SQL plan management, because like I said, it is a preferred method and optimizer can use it when you have set the flag for the captured baseline to enabled equals yes and accepted equals yes. You can capture more than one baseline for a particular SQL ID. Also, if you want to use one of the baselines as a preferred one for optimizer, you have to set 3 flags: enabled yes, accepted yes, and fixed equals yes. Now here is the thing which again is little bit confusing for a lot of people I have worked with or talked, even in Oracle support. You have to understand that you have captured a baseline, but optimizer has to go through it next time it hard parses, and behind the scene it will use the stored outline, which normally it creates. So this, we just stored those stored outline and other related information so that we can replay that information, and we have to replay that stored outline 100%. So all the stored outline hints which have been stored as part of the baseline 100%, and then only we can use it as a baseline plan. Now if you have one baseline, it will try to use it and reproduce it. If it cannot reproduce it, it will see if there is a second baseline or third baseline until it has exhausted using all of the baseline and see if it can use at least one of them. If it cannot use any of the baseline to reproduce that plan, then it has to create a new plan, just like as if there was no baseline created, and then that plan will be added to the list of baseline with enabled yes and accepted equals no, and the SQL will continue the execution. So that is very important to remember, because baseline is like all or nothing. So all means it will reproduce 100%, nothing means I could not reproduce 100%, thereby I cannot use it. Whereas some of the other methods like even COE profile, if I could not reproduce every single plan state, but say 90% of them or 99%, still it will use that COE profile. As a result, COE profile may not guarantee 100% plan reproduction, whereas SPM, if it can be used by optimizer, it guarantees 100% reproduction of previous plan. Now let's go back and talk about those three steps now. One is plan capture for the baseline, and there are at least 5 different ways you can capture a baseline plan or plans. Easiest thing is to set optimizer capture SQL plan baseline equals true. By default it is false, and I prefer that you capture at the session level as and when possible. Also, you can add some filtering condition through the DBMS SPM package to even further restrict what you capture for baselines. You can also capture a bunch of baselines from cursor cache in your SGA memory. You can also create baseline from AWR repository. You can also capture one or more baselines from SQL Tuning set, which you may have used as part of your tuning effort, and took that tuning set from one database to another, or even you can use it in same database. And finally, you can move your baselines from one database to another using pack and unpack method of SQL plan baseline. You can find more about these steps in our Oracle documentation. For the timing, I have not added, but I'm thinking of adding a few slides to at least show quickly how this is done for each of the steps in future. Now, once you have captured the baselines, then the SQL will need to be hard parsed, and when it hard parses, optimizer will try to use, and that is the second step for plan selection. You do not need to do anything, because by default we have set optimizer use SQL plan baselines parameter to true. So if you have a baseline, if it is at least enabled yes, accepted yes, then optimizer will try to use it. You have to keep it in mind that SPM is not supported for distributed SQL as of 19C. Also, there are severe restrictions on using SQL plan baseline intentionally for any sys-related queries, like a query on, say, all directories, for example, which I was working with for a customer recently. There are specific bug fixes which is enabled by default, and thereby it prevents use of SQL plan baseline for any queries on sys or recursive SQL on sys objects. Now here is an example where I have captured 2 baseline plans. You can look at the plan name, look at the last part. You can see that both the plans have been enabled, yes, accepted, yes. None of them are fixed plans. I captured it in 2 different ways. And also notice that we also captured the cost, and optimizer will always try to use the plan with the cheaper cost even in the baseline plans by default. So since I have not fixed it, it will try to use a better plan, but that better plan is look with using the costing. So in this example, optimizer will try to recreate this baseline plan with cost 5. If it can 100% reproduce the related stored outline hints, then it would be able to use it as a baseline. If it cannot, it will go try to reproduce the second plan with cost of 35, try to reproduce. Again, if the plan reproduces 100% like it was before when we captured the plan, then it can be used. If none of them can be reproduced 100%, then it will capture a third plan with a different name here. It will show enabled yes and accepted no. So hope I made that point clear now. Okay. Now, here is an example using same sample SQL. So you can see same SQL ID, but it has a different plan. And I'm able to use it as a baseline for same plan now because I disabled the COE profile to demonstrate capturing and using a different plan. So that's why you see a different plan here. And the note section is very helpful when you look for the plan details. And that's where you can validate whether you are able to use any of the plan stability method or other useful information to determine how this plan has been generated by the optimizer. You can use dbms spm.configure procedure and you can add different configuration changes or modify some of the changes. You can add some filtering conditions about which schemas and their baselines you want to capture, things like that. So please feel free to explore that. Also, we have enhanced the SPM further in 19C. We call it automatic SQL plan management. And it works this way. So by default, you are supposed to have the plan capture done manually, right? And then plan will be selected, and later on at some point, the nightly job like sys auto SPM evolve task, which is the third option of plan evolution. So this auto task actually evolves some of the baseline plans. Now, when automatic SPM is used, it uses the evolve task parameter and any configuration, and also this sys auto SPM evolve task to also choose some of the baselines on our behalf, on behalf of the DBA or developer, based on certain criteria and configuration, and it will have those additional baseline for plan stability of some of the SQL. So that's the idea, to kind of have less intervention and have some of the plans captured so that Oracle can help you provide plan stability like you were doing manually. Okay, but keep that in mind. These alternate plan source and alternate plan baseline, these are configuration parameters. Their default value or the set value have to be auto and auto to use automatic SQL plan management feature. Sometimes it may not be auto. Like when I was testing with 19.4, I found alternate plan baseline has the value existing and alternate plan source is auto. But before that, it already captured some baseline for me, and I could see that by querying DBA SQL plan baselines view when it was a 19.1. Now, let's take a quick look at some of these parameters differences, configuration parameter differences. Let's focus on these three alternate parameter names. So in 19C, you can see their value and notice how they're different in 18C or 12.2, and they did not exist in 12.1. We also had a limit by default to capture up to 10 baselines, up to 18C. Now it's unlimited, but if you don't want it unlimited, you can change it to some other value like 20, for example. Now there are various reasons why sometimes SPM cannot be used, even if you have correctly captured it, set the flags to enabled yes and accepted yes, or even enabled yes, accepted yes, and fixed yes. I have seen for some of the customers. And here are a few reasons, but this is not the exhaustive list. So just a few reasons. For example, if you change the table definition compared to when you captured and the current table definition, if they are different, sometimes we see that SPM will not be used. If you change your index definition, so I recently worked with another colleague, and for that customer, their baseline was not used when say they had an index on 3 or 4 columns, but later on they added another column. They kept the same index name and all. Their table definition was not changed, just the index definition, and that was preventing the SPM usage. Once we compared and changed the index back to how it was before, now the SPM can be used. If you make an index unusable or invisible and that index is part of SPM stored outline hints for usage, then SPM cannot be used. Sometimes it could be a known bug, so it is good idea to verify if you are having problem to use SPM. It is good idea to check our release update, latest release update, and the release update you are on, or any known bugs on that particular release to see if that is preventing the use of SPM. There are few known bugs, so you might want to check. If you have exhausted everything and you think that it should work but not being used, then we would need a reproducible test case so that we can recreate the problem in our test system and preferably in our latest release as well of the database software. And if we can reproduce in one of the releases, same release like yours or in the later release, then we may end up filing a new bug for you. And then we involve our developers if they also can reproduce and agree that it is a bug. So we'll have a bug fix in future for that particular problem. Now let's talk a little bit about the new feature, SQL Quarantine. It is a brand new feature in 19C. It helps application avoid running some SQL over and over again, because sometimes you may see that I had a good plan, then it changed to a very bad plan, and that is so time consuming that it is affecting the performance of your application. So you rather want to control or get hold of that SQL, have control over it, or control over the particularly bad plan and stop it from running that particular bad plan. And that is where you can control the runaway SQL, right? And that's how it complements the SPM. Because with SPM, you want to use one of the few plans which you have captured. Now here you are stopping a plan from running so that you are again narrowing down the number of plans which you want to use for a particular SQL. So we have a new package, dbms_SQL Q, which is used to kind of manage the SQL quarantine feature. It can automatically add some SQLs if it meets certain criteria for being quarantined. You can manually add some of them as well, and if you do not need to quarantine anymore, you can drop the quarantine. Like in SQL plan baseline, you have seen there is a plan name. Here we also create something similar. We call it quarantine name, and you have to use that to manage those quarantine objects, whether you want to disable that quarantine object or drop it. Now to create Here is an example. You can use DBMS SQL queue.create quarantine by SQL ID. You provide the SQL ID and plan has value. If you know a specific plan, in this example, you can see that I want to quarantine one of the two plans so that I do not want to use that plan in future, the plan ending with 1476. So it will let optimizer still use the plan ending with 117, or it may generate even a new plan, but it will stop running or using the plan ending with 1476. Once you have done that, you can see it created a quarantine name. It's a system generated name. You can find about it from DBA SQL Quarantine view. And notice here we also use signature, plan has value, name, and so on, but we do not have a SQL ID here. So I would have liked to have a SQL ID, even if I generate signature for the SQL Quarantine as well as for the baselines. I think that would make things easier to identify the SQL related plans and so on in terms of management. Now, if you do not need a quarantine, you can drop it using drop_quarantine procedure. Here is an example, but I prefer to disable a plan or a quarantine or a baseline or a SQL profile or COE profile instead of dropping it right away. So that way I can disable that particular object and verify how the SQL runs. And then if I decide that I do not need it anymore, then I would go back and drop that particular object, in this case SQL Quarantine object. Now, if you have enabled SQL Quarantine for a SQL, and if it ran into it, you will get an ORA error, ORA-56955, and it will indicate that quarantine plan used error. So that means I tried to use that plan and it did not use it. That's what really that error means. Now you can also add this quarantine hint as you see here, exactly as it is. In a particular SQL, if you want to prevent that SQL from running, irrespective of whatever plan it could use. For example, if you have a bad job with bunch of SQLs, you know one of the SQL is bad and you can get by not running a particular SQL, but you really want to finish rest of the SQL and can manage running this quarantine SQL in some other way, then you can add this quarantine hint for that SQL, and you can, instead of not able to run that whole bad job, you can finish most of the things in that bad job, for example. Unfortunately, SQL Quarantine has some restrictions. Right now, it works only in our engineered system, in the sense that you can use it in the Exadata machine or Exadata cloud services, where also we use Exadata behind the scene. So you can use it there, but for testing purposes, I set _Exadata feature on to true in an Oracle 19c Enterprise Edition database, restarted it, and I could validate this feature. Now you have to be careful whether you can use this hidden parameter or not because of the licensing requirement. So if you have any doubt, please check our licensing guide. And if you still have doubt, I would highly recommend you contact our sales team to make sure whether you can use certain feature, not just SQL Quarantine, any feature, whether it is licensed or not, you might check it, right? That's always a good idea. But just so you know, the SQL Quarantine feature is very similar to what we already have in Exadata sales servers. There also you can quarantine a SQL. By SQL ID, you can also quarantine some of its plans, and you can remove the quarantine later on. So here is the link for the licensing information guide. Please feel free to refer anytime. And this is the note I was talking about. loading hinted execution plan into SQL plan baseline. I find it extremely valuable note about how you can use SQL plan management feature in a non-invasive way without changing your particular SQL and then still maintain a better performing plan. So that may come handy someday, I hope. Since this is a recorded presentation, I'll skip the Q&A part. And I would like to thank you for listening to me on this important topic, SQL plan stability method using SQL plan baseline and SQL Quarantine of 19C database. But these two features, you can use it even in the new release 20C, just so you know. Thank you.